Hello, welcome to our channel once again. So today I'll be using this document for us to discuss what SWORD is all about, and we're going to be doing some examples and some exercises. So what is SWORD? A SWORD is an irrational number in root form. Remember in our previous video we talked about number system and we encountered some number that we consider them being irrational. For instance, you have number a all over b, whereby the numbers are not terminating decimals, so we call those numbers irrational. So example of sort are root 2, root 3, root 5, root 6, root 7, root 8, root 9. Now the following are not sort. For example, square root of 4 is not a sort, because square root of 4, clearly we can see that is equal to 2. We can take the square root of 4, which is equal to 2. Similarly, 9, 16, 25, they are all not sort, since we can simplify them to a particular number. Now we have some rules, some basic rules in sort. We have, when you have two numbers under the root form, it's the same thing as taking the two numbers separately. Similarly, when you have them in quotient form or division form, it's the same thing as taking them separately. So for instance, if I have root 6, clearly this can be the same thing as root 2 multiplied by 3, and similarly is the same thing as root 2 multiplied by root 3. Good. The same thing goes for the division, right? The same thing goes for the division. If I have square root of a all over square root of b, then I can have it as just a single square root of a all over b. This is a rule in sort. So moving forward, I can say that we can have, for example, all these 75, right? If I want to simplify this, I will look for a factor of 75 that is a perfect square. In this case, it's 25, right? Then instead of writing 75, we can split it. We can split it to have 75 is equal to 25 multiplied by 3. Then we separate 25, since we know that 25 is a perfect square. Square root of 25 is equal to 5. Can you see that? Square root of 25 is equal to 5. Good. Similarly, you can walk down this example. Then before we continue, let me give some other rules that we have in sort. So some other rules, let me add them here. We also have some other rules. When you have x plus y, right, you have the square, all of them, right? This should not be taken as square root of x plus square root of y. I repeat, it is not. When the sign in between them is addition, this is not the same. It is not the same. Similarly, when you have square root of x minus y, it is not taking the square root of x minus square root of y. It is not. Good. So with that being said, let's see how we can simplify some other square root that we have. Now, for instance, if you have this, now we can put them in together because we know that this is square root of 24. Remember, this is our rule. We can put them together. 24. Can I get a perfect square in 24? Yes. 4 multiplied by 6. I can take the square root. I know that the square root of this should be 2, and then this should be root 2. So that is your answer. Now, adding and subtracting sort. How can I add or subtract sort? Now, this is very simple. To add sort or subtract is very, very simple. We are in this particular environment right now. How to add sort? Now, you add sort, simply take the sort form and add together. For instance, let me give you a general rule. If we have, let's say we have, if we have a root x, right? Then plus we have b root y. These two can never add each other because this rule, these elements under the square root sign are not the same. They cannot add each other. But if I'm giving a root x plus b root x, since they are the same, your answer is going to be add these two together, which is a plus b, add them together, right? And then take the square root. It's like factoring the square root out. So this is clearly simple. Similarly, if you have subtraction, if you have a root x minus b root x, simply take that 1a minus b, very simple, right? Then root x. This is valid. This is valid argument. So for instance, we have, you see, 3 is in the square root sign. We have 5 root 3 minus 2 root 3. Then it's very simple. We can just subtract 5 minus 2. This is 3 root 3. We have 4 root 2 minus 3 root 2. So in this case, we can put out 4 minus 3, right? Then root 2. That's how we got root 2, because 4 minus 3 is actually equal to 1. Good. So similarly, we are going to be having some other examples down the line, which is just what you're seeing in past question paper. Good. So let me take it up. So similarly, express 50 as a solved in simplest form. I know that it's just 25 multiplied by 2, then square root of 25 is equal to 5. Very good. Then 2. Similarly, that's how you express this. You can simplify this 16 times 3, which is here. Then you have 4 root 3 minus 3 root 3. So these are pretty simple exercises that you can walk through. The answers are there and the steps are there. And then similarly, if we are given that we have, for instance, more example, if you are given square root of x squared y cubed. Now, how can I express this? I can express this as what? I can separate it, right? X squared can be 1. Then I will now multiply it. Let me separate them. We have square root of x squared multiplied by square root of what? Y cubed. This is the same. Now, square root of x squared, I know that this will cancel out. I'll be left with x. Then square root is going to take one of these. Then I will left with multiply by, can you see this? Y squared multiplied by y. Is that not so? Good. So I'll be left with x. This will go. Y, this will remain. So I have square root of y squared multiplied by square root of y. Can you see? This can also go. So I'll be left with x multiplied by y multiplied by square root of y. So it's very simple. Just follow the simple algebra, then you get the square root. Then where we are going to stop for today is when we say rationalization of denominator. Now in contrast to all other examples, when you have the square root sign in the denominator, it is an invalid argument, because at some point you cannot have a negative for the square root sign, and then you can't divide by 0. So when we have a solid in the denominator, it is better to simplify it further, and we simplify it using the concept called rationalization. Now you have square root of 2 in the denominator. To rationalize, you multiply both sides. You multiply the numerator and the denominator by what is in the denominator. For in our case, you can see that square root of 2 all over square root of 2 is actually 1. So you are not changing the particular expression. You have 5 all over square root of 2, right? and you're multiplying it by square root of 2 upon square root of 2. So this is very simple, but by so doing, you are going to get rid of that square root sign in the denominator. So 5 multiplied by square root of 2 is 5 root 2. Then square root of 2 multiplied by square root of 2 is the same thing as square root of 4. So what is square root of 4? It is 2. You get it? That's why they got this. So to show clear working, express this in all the terms, in all the 4 steps. Similarly, this, you see, you have 7 all over square root of 3. You simplify. So the steps you're going to put here now is going to be 7 root 3 all over square root of, you can say 3 squared, or you just put 9. Then this is going to go out before you get this. So what's the step that is omitted here? Square root of 6 upon, you can say square root of 36. Then this is going to give you square root of 6 over 6. Now that is that about all about rationalization of the denominator. Now we have the last step. The last step is when you are given the square root that have 2 or 3 root in the denominator. How can you rationalize? Right? You are given to rationalize by more than one root sign in the denominator. When the denominator is by surd. So what do we mean by binomial surd? Binomial surd. Now, binomial surd is any surd that is in the form, maybe let's say square root of x then plus square root of y, right? Similarly, maybe you have let's say you have x square root of y then minus y square root of x. This is binomial. The surd are not the same, then the elements are not the same, so we call them a binomial surd. A binomial surd. So you may have a case where you have a binomial surd in the denominator. So how are you going to go about that when you have a binomial surd in the denominator? For instance, let me take this way. We have a binomial surd in the denominator. So right now, let's look for example. When you have 5 plus root 3, right? Now it is a binomial surd, and if you find it in the denominator, for instance, you have 5 plus square root of 3. How can I rationalize this? I want to get rid of the surd in the denominator. It's very simple. You multiply this by what we call the conjugate. What we call the conjugate. Conjugate. So the conjugate is simply negate that particular binomial, the middle term. So for instance, if I have x plus y, so the conjugate is going to be what? It's going to be square root of x minus y. Similarly, if I have square root of x plus square root of y, so the conjugate is going to be what? Square root of x minus square root of y, right? That's very simple and clear. Now, so if I want to take out the square root sign from the denominator, is very simple. All I need to do is to multiply through by the conjugate. So in our case, we have 1 all over 5 plus root 3, right? 1 all over 5 plus root 3. How can I take the conjugate? So I'm going to multiply this by 5 minus root 3 all over what? 5 minus root 3. So if I multiply 1 multiply by this, I'm going to get 5 minus root 3. Now if I multiply 5 multiply by 5, I'm going to get 25, or 5 squared is the same thing. 5 multiplied by minus root 3 is minus 5 root 3. So I did this and this. Second, I do this and this. Now for the third one, I'm going to do this and this and this. So I'm going to get plus 5 root 3. 5 multiplied by root 3. Then lastly, I'm going to do plus root 3 minus root 3. Multiplying them together, I'm going to get negative. Then I have square root of 3 all squared. This is going to go. So I have 5 minus root 3, because this is going to be this. And then lastly, I'm going to have 25 minus root 3 plus root 3 is cancelling out. Then I have minus 3, right? So this is simple. We have 5 minus root 3 upon 25 minus 3 should give us 22. Now this is very clear. You can go further by simplifying, since the denominator is the same. Then minus square root of 3 all over 22. And that's that about it. So I will see you guys in the next lecture.